geospatial part. So these two things we used from ARML 2.0 to create this experiment. Now, there are several other aspects that are covered in ARML 2.0 which we as a group find they're valuable, but we just didn't implement that in the experiment yet. So the next step is, as said in this slide, is to identify where, for us as the browser vendors, it makes sense to proceed with some level of interoperability. Because some things are harder to implement cross-browser than others. Like, for example, something like computer vision is very hard to standardize because it's binary. It's, there's lots of stuff that you have to change in the application itself. So we will add some bits and pieces to the interoperability experiment. Of course, this will also benefit ARML 2.0 because it will be improved. So that's kind of that's the outline. That's where we want to move forward in both the experiment and ARML 2.0. We want to take bits and pieces from ARML 2.0, put it into the experiment, which will then, of course, feed back into ARML 2.0.
Comments, anything? When are you going to support Curve and the Argon project? Thank you. Mike, when are you going to support Curve and the AR interoperability project? Shortly after Blair. Tony, did you have a question or comment?
I was wondering, so what is still sort of left off from this is what you agreed on, what's still sort of left off from the capabilities that aren't interoperable? And then do you have a sense of what proportion of the world are now fully interoperable?
Yeah.
Oh, that's good.
A slim portion.
Wait, that's a very, very concise answer. That's not accurate.
Well, no, let me finish that sentence. Or actually, but let me finish the statement. In terms of the feature set that we could have in AR applications, it's a slim portion. Because all we do is synchronizing on the geospatial information and the metadata that is sent to the browser. From a content perspective, the content that has been created on the AR platforms, 90% approximately, we estimated, of the content is exactly what we just made interoperable. Only 10% of the people use more extended, more complicated features. So we did a good job in that, but from a feature set perspective, there is more to add. And as soon as, of course, more and more features are being added, we will see that these features will also pick up.
And what are the more complicated features that are current?
Some examples: computer vision, 3D models, the visual representation of the digital object. Right now, it's really just the data. So these are an animation. We all support some level of user interaction. We use JavaScript and stuff like that. That's harder to standardize or to make interoperable between these browsers. So these are the harder parts.
But definitely the 3D models, all the different browsers use different encodings and formats for managing, storing the 3D assets. That's one. But that's actually a relatively easy one to get over because adding an additional 3D format that you support that made you interoperable with everybody else is not huge. That's a low-level engineering milestone to reach. Much more difficult is the fact that very few people have created 3D assets for augmented reality experiences. So how are you going to create that? Just before I move there, one of the aspects, if I understood correctly, your question that was almost included in his response, is that how many of the existing layers, worlds, or channels are currently accessible in this format? The answer is that depends if the translation service that was developed for the prototype has access to all of the experiences that are available in that ecosystem. In the case of Layer, Dirk has put the translation service so that it has access to virtually everything that's ever been created in Layer can now be opened in Genio or in Wikitude. I don't know about the other groups. I don't think that's, no, it is the case for Natalia too.
As far as
he's made it.
he's made the application available, but not the endpoint. So, but we're going to be launching that soon as well.
And then the other sort of subtlety, I'd say, is that there's as you'll see on that proof of concept page, some of the browser, I think it's only Genio that you can click on that link and it'll directly open an AR experience from
From the browser.
From the browser.
From the web browser.
HTML,
Yeah.
from the normal web browser, you click on the link and it'll go ahead. The others, the client applications don't have support for recognizing what, oh, I just hit this HTTP. What do you want to do with that? And
Yet.
Yes. So I think those are things that have to be brought in for that commercial launch and getting it out to everybody.
Exactly. So basically, the version for the experiments already do support these types of things. It's just a matter of launching these things and communicating.
Yeah, but when it's
Can I just clarify something? I pulled up the ARML 2.0 spec. I see that 2 of the people whose names are honored are in the room, but am I correct in understanding that absolutely nothing supports it?
well, now the translation services support it, and the 3 web browsers, they don't even support it. It's the translation service only. that support
Right.
it.
And in the entire world, nothing else, really?
That's correct.
That's true.
That's correct.
Yeah, I mean, we were on our way to doing that, but
Ran out of steam.
ran out of money, ran out of here. But yeah, I mean, in Argonne, it should just be a matter of doing XSLT on the material, but there's always other issues. We just haven't had time, but that's the goal.
And we learned some things about ARML 2.0, even implementing it only on the server side.
Right. I mean, it doesn't really matter. ARML 2.0 is an exchange format. It's something like Collada for 3D. It's an exchange format. So it doesn't necessarily have to run on a mobile device. It's really for describing an augmented reality scene and interacting with it.
Well, we could see a future, what we wrote, we did a roadmap that kind of said, okay, today you support it only in the server as a translation service, but later you could have a platform for AR experience publishing that allows you to generate an ARML 2.0 or CARIF capable file or set of files. And then in the future, a browser could be published that supports the reading of a CARIF file. So you can see that you can go in different evolution, different speeds on the server and the publishing side and the client. All right, I want to thank you again. Is this anybody? Yeah, there's a couple of questions here.
2 direct questions which I would accept the direct answer. Number 1, assume I'm building a 3D model library specifically so that AR browsers and applications can go freely filter those models and use them. What format ought the models be in?
That's a very good question. All the 3 browsers do support a different file format. So there's no straight answer to that.
Second question, should AR browsers exist or should Apple and Google introduce them directly into their mobile browsers? Or mobile platform directly?
Well, I definitely want to second Blair and what he was saying. I mean, my vision is that AR is moving into the browsers, into the web browsers. So we don't have any particular app that we have to launch to find stuff around us or search for something. But we're not there yet, as Blair was mentioning. So yes, it should go into the browsers, into the web browsers. But right now we have to deal with AR browsers.
What about the camera app instead? What's your position on should it just be a part of the phone's in-brand camera app with web extensible widgets that can be played back?
You mean right now the native camera on the phone?
Yes. Native camera app.
The native camera app. Well, I mean, it depends. I think there is still a use case for taking a picture, for example. And I'm not sure if I want to launch take a picture. And I don't necessarily have to have AR content in a native camera. So I think that still is a viable use case for me. So I think it makes sense to have that application. But then again, of course, the camera has to move into the web browser to do some stuff like AR.
We're now, great.
Thank you.
Thank you. You're going to hold that thought.
Yeah. Oh, okay.
Thank you. Now I'm going to invite, who's next? I have to get my, is it Paul? Is it Enterprise or, yes it is. It's the two of you sitting side by side in that there. No, you're with Mike. It's John and Paul that is this next session. All right, so I'm going to introduce Paul. He showed up one day, and you know that Boeing engineers in 1992 coined the term augmented reality. Do you know those guys that you know?
I know who they are, but I don't know the person.
Yeah, you don't need to know them personally, but it certainly is, you know who they are.
You're going to see a slide where work that Tom Connell and I are doing.
Oh, that's fantastic. So there's been a long-standing association between this concept, the term, and the company, the Boeing company. So Paul and colleague Lori internally to Boeing have been doing some internal workshops with their vendors and suppliers to talk about how to use AR more effectively in their production facilities. And that's been going on for a year and a half. And over that process, more and more of the research that they've been doing is being released to the rest of the world. So in our Columbia University, the 9th meeting of the AR community, one before this, with the pleasure of Paul's participation, though he didn't speak. And we're happy to welcome him now to the podium to tell us about what is happening the very latest. She's only, what, 6 months or a year old?
Almost the very latest. Well, thanks for the introduction, Christine. So yeah, I'm Paul Davies. This presentation is going to take a little bit of a different flavor than some of the other ones that you're going to find out. We are a large company looking to use and benefit from these technologies. And we believe we can do that through improvements in efficiency of manufacturing, amongst other things. But that's my focus. I work in the manufacturing domain in Boeing Research and Technology. So my goal is to bring in new technologies that we can implement inside the company to basically improve our manufacturing processes. So one of the things I've been focused on for the last, probably 5 or 6 years, maybe 7 years in total, has been augmented reality. And probably in the last 3 years, I would say heavily focused on this manufacturing application of it. So what I'm going to talk about is going to be kind of a snapshot, kind of a high-level overview of some of the work that we've done and where we're at, and I've got some videos and some examples of the implementation we've done on the shop floor. I'm going to cover a little bit about the system architecture and how it works, but it'll be kind of high-level content. So I'm going to give a brief background to the technology and its extent to what's being used in Boeing. Like I said, cover the system architecture, I have a block diagram, I got some examples. Then I want to break down into the system components a little bit. As you're going to see, we've kind of prototyped what we're calling a pilot AR system. So I'll go through a couple of the components of that and discuss why we did what we did. And then I want to talk a little bit about a user study that we've just actually finished with Iowa State University. And I have some results from that also. All right, so there's been a number of projects in AR in Boeing research over the past decade or so. As funding comes and goes, so do projects and people. But the one that seems to have gained a lot of traction over the past 3 years, the project is called Assisted Assembly. And it looks at a couple of different technologies aimed at, like I said, improving efficiency in manufacturing and assisting the technician or the mechanic in building something. One of the tasks of that project is augmented reality. So the purpose is to develop this prototype system, and as you'll see, we're not really into these underlying algorithms or browser development, things like that. We're more into kind of bringing in technology that already exists and using it in a way that benefits us. So we want to deliver spatially registered, useful information to builders on the shop floor, whether that be work instructions or design intent, CAD models, lots of stay-out zones, tribal knowledge, lots of things can be useful. So we've been working on this system that can deliver that stuff, and an end user can visualize that on the shop floor. And then we want to implement that system as a prototype or a pilot with our customers, which would be either Boeing Defense or Boeing Commercial. We're the research group that sits kind of in the middle of those two. So we believe if we do this, there's a number of benefits that we're going to see. Reduction in assembly errors. We expect people to make fewer mistakes if they better understand the work instructions. Reduction in training requirements. We think we can train people in kind of the basics, the low-level tasks that are applicable across lots of different programs rather than the specifics of one program. Reduction in assembly time. We expect things to be built quicker if people can more quickly grasp the task at hand. We think there will be an increase in the recall of work instructions when people are presented with instructions in an augmented way. They're more likely to remember them. And all this leads to an increase in first-time quality of the product. And that last bullet there is kind of an interesting one. We have like an aging or mature workforce, I'll say. So we're going to have a lot of people leaving over the next 5 to 10 years, and we need to capture the knowledge that they have in their head. A lot of that knowledge is not written down, it's not documented in the work instructions, it's just things that they have learned from doing the job for so long. So we think there's a lot of potential for this kind of technology to help with the transfer of that knowledge into the next generation of workers. So here's the block diagram of the system we have kind of put together. I'll run through it briefly. We're using a motion capture system for tracking the camera and tracking the assembly, understanding the location of the pose of our camera and objects. We did a lot of work with trying to use some fiducial marker tracking, markerless tracking, and things like that. But we quickly realized that for various reasons they weren't going to pan out the way we wanted them to. So we've converged on using motion capture systems for now. We have some research on other technologies going on, but our kind of baseline system that we use uses Vicon motion capture. So we mount these tracking systems in the work cell, and we're going to be using the AR technology, and then the user can take the tablet PC and walk around with it, and it's tracked by the Vicon system and get the position that way. So that's what's in the bottom right-hand corner here. Typically, in most of our applications, we're showing like the design of the product overlaid onto the view. So just take like CATIA models or Proe or whatever they happen to be in, and then that would be our digital data that we would overlay. And then all this stuff in the light blue box here is running on the tablet PC itself. We wrote our own user interface, some calibration algorithms, things like that, to kind of tie it all together. And then for rendering, we use the diffusion environment, which is from a company called Total Immersion, which I'm sure some of you are familiar with. It's kind of interesting here, these CAD models, even within Boeing, because Boeing is kind of a patchwork of other companies that we've kind of acquired over the years, even different programs use different standards for digital data. Some use CATIA, some use Proe, Unigraphics, NX. So it's very difficult to make one AR system that can take any of those contents, any of those formats and use it. And I'll talk about that a little bit later. So here's a couple of pictures of places we've been working. This picture is actually a couple of years old now, maybe 2 years old. This is an Intelsat panel, Intelsat 27. Interesting side note, this is actually sitting at the bottom of the Pacific Ocean now because sea launch failed when it tried to launch this satellite. But, so I'm stood here using this tablet PC, it's running Windows, and it's, you can see the Vicon tracking markers stuck onto it, and overlaid onto the screen there's something like this. And it showed me the digital design, the CAD models for those parts spatially registered onto the panel. So this can really help speed up the process of the mechanic understanding what his job is, and something like a waveguide, which our all these little pieces here, where you have lots of them, they look very similar to each other, and there's no immediate, clear way in which they need to be oriented. So this really helps them understand the process quicker and what the product is supposed to look like when it's finished. In this example, we actually broke this down into three different layers, because we didn't want to put too much on the screen at once. So through the user interface, and I'll show you that in a little bit, they can actually select whether they want to just see like one part number, or all harnesses, or all structure, or whatever is relevant to them at that time. You can see that from there. All right, so here's a video. We were exploring different uses for AR and how we could apply it. So we thought about using color-coded overlays to show things that are in flux perhaps, or moving and not in the final position. This is an F-15 fuel pump, and that lid there that you can see being put on will actually fit in 3 different orientations. The holes will line up and allow you to put the bolts through in 3 different orientations, but only one of them is correct. So we thought a nice application would be to use the overlay to illustrate the correct orientation. And then you can see those bolts going through in the proper sequence. So the colors there are really just indicating when it's red, it's still moving. So that's not kind of in its final correct position or orientation. When it turns green, it is. There's no check going on. The system isn't testing to see whether it's been installed properly. That's not some kind of feedback. That's just, it's a one-way information flow. The system is telling you to do this, and when it goes green, that's how it should look. So I'll skip this, goes on a little bit, so I can skip this. All right, some other places we've highlighted this. This is the commercial Boeing commercial aircraft. The 777X program are looking to completely re-engineer the way we make the wings on the 777X. So they're looking at a whole range of new technologies, all aimed at making the build faster and cheaper and more efficient. So one of the things they were interested in is AR. So this is actually a horizontal stabilizer which goes on the way up, right at the back of the aircraft. And the instructions here are animated. They're showing how to install this big white rig plate here, and you can see the green overlay on the tablet. Okay, so I want to jump into some of the system components a little bit. So I mentioned we were using tablet PCs. We use a motion computing tablet which runs Windows, just because everything else that Boeing does is running in Windows. We do have programs that are trying to bring iPads in. They've had mixed kind of success, but we're so heavily entrenched in Windows. So we made a decision to stick with a Windows tablet, which means we're limited to what we can choose, but we did find this nice model for motion, and it's ruggedized and it's designed for harsh environments, factory shop floor use. Then we realized that we wanted to have a depth sensor on the back, and it didn't have one. So we made this tablet holder that is custom designed for this particular model of tablet, and the tablet snaps into it. And it allows us to mount the tracking markers here, mount the sensor on the back that gives us depth data, and I'll kind of explain why we need that in a second. And then lastly, it allows us to clip the tablet onto this holding arm, because one of the big issues is someone can't hold a tablet and do their task at the same time. So we need to keep both hands free. And in the absence of wearable technology that's going to meet our requirements, we're still using these handheld devices. One of the hot topics that we've come across is, and it may be unique to kind of to the more industrial application of AR, is the accuracy requirements that we're stuck with. If we're trying to show a technician where to drill a hole or where something needs to be mounted, we need to do that very accurately. We can't really accept millimeters or centimeters of error. So we put a lot of work in last year into how to calibrate all these system components so that we can guarantee that the overlays do show up in the right place, or they don't show up at all. It's important they either show up correctly or not at all. We don't want them showing up in the wrong place. So to that end, we developed some calibration algorithms. I mentioned they're all written in MATLAB. The top two here are really just kind of calibrating the system components like the Vicon system and cameras, distortion, those are kind of well-known techniques to do that. And then the bottom two are things that we wrote ourselves. One is to calibrate the tablet coordinate frame. We need that coordinate frame to line up to the camera exactly, or wherever the camera may be on the tablet. And then the other is the assembly coordinate frame. We need to line up that with the solid model coordinate frame, and we need them to be precise. So we wrote these systems, not overly complex, pretty straightforward. The assembly calibration involves touching 3 points on the assembly using a tracked object, which we track with the Vicon system, and that allows us to calculate the transform from the solid model to the shop floor, the thing that the assembly sitting in front of you. Camera calibration, we observe a marker that we track visually. Simultaneously, when we're tracking it from Vicon, we calculate the offset there. So I can go into more details about this maybe during the breaks if folks are interested in what we did. Next thing we looked at was occlusion handling. We wanted an effective way to make sure that models that are on the screen are only ones that you can see from that perspective, from where the user is stood, and here's why. So a couple of examples on the left here. These parts are all on the other side of this panel, so you can't see them from where you stood, and perhaps a little more subtle and maybe more important, or more obvious, is this one here. From where I'm stood, this unit where the cursor is right now is actually on the other side of a drop-down fin, and you can't see that from where you're stood. So if I'm holding the tablet, I don't see the unit, but I see the overlay can lead to some confusion. So we wanted a way to handle that and to mitigate some of those confusions. So that's what we use the depth sensor for on the back of the tablet. I think I may be preaching to the choir with this slide, but this is some of the data that we get from the depth sensor. On the left here, this 2.5T point cloud. We use that to determine what is closer to the camera for every pixel that the camera gives us. So we want to know whether there's a real object closer or a virtual object closer to the camera, because that determines what we should draw on the screen. If my hand is closer than, say, a cat model, I want to see my hand, or if the cat model is closer, I want to see that. So this is the result of that. Here's a demo of the occlusion handling. The red thing is real, and then the purple jig is virtual. And then you can see as we put our hand through it, it includes the virtual object. So it's a way to kind of more accurately merge the virtual and real worlds. You can see there half the object was hidden by the table. So if you can picture kind of complex assemblies that have wire harnesses and units and all kinds of mechanical things, and sometimes even moving in the scene. It's really important that we're able to handle these occlusions so that the scene is much clearer and more obvious to the user. Okay, I have a couple of slides on the user interface. Again, we put this together. It just uses MATLAB interfaces with the diffusion and the Vicon tracking system. It handles kind of things like calibrations and the assembly the person is working on, the workflow, the work instructions they need to be retrieving, things like that. It has two tabs to it. First is the setup tab, where typically you just kind of connect to the tracking system, you load the CAD models, you tell it what work order you're doing, it'll pull up the appropriate work instructions and things like that. The second tab looks like this. These are all the tasks, so depending on the assembly you chose, it loads all the tasks that it has for that step, and then you can step through them one by one with these buttons. This kind of sits on the right-hand side of the tablet screen, so when you're holding it, it's kind of convenient for your thumb to toggle through those steps. So I mentioned we worked with Iowa State University last year. I'm going to talk about the study in a moment, but we put the system, we installed it at ISU for a couple of months, and then they ran 60 participants through. We were trying to understand really what are the benefits of using AR for work instruction. Well, really, are there any? First of all, what can we what can we expect from it? So the first thing we realized is that the system really wasn't ready to be used by people who didn't develop it. We were putting it in somebody's hand, and for instance, one of the first things we needed to add this arrow to the screen, so whenever the current instruction is not in the field of view, that arrow pops up and tells you which way to look. Because we would, and it's kind of remarkable, even after we had kind of demoed the system to, say, one of the participants, we would give them the tablet and then they would just look at their shoes with it, and they would say, well, it doesn't work, and we'd be like, well, look, point it that way. So once we put this arrow on there, it really helped. People kind of got that instantly, and then we didn't have that problem anymore. Let's see, study is next. Okay, so all up until this point, this video kind of captures the latest configuration of the system. This is from the KC-46 tanker program. And we're in the boom shop. The boom is the long thing that connects the receiving aircraft to the fueling aircraft. And this assembly here is called the torque box. It's where the boom attaches to the belly of the tanker. And so we're showing these animated CAD models moving into place to illustrate how that thing gets assembled into the jig. You'll see the inclusion of work here, hiding behind there. And you'll see in a second there's that pin that goes through the top that attaches it, and there goes, you can just about see it there, it's a little bit transparent. So this goes on for like 5 or 6 steps, and by the end of it, the whole part is hanging in the jig there, and someone will be able to build it without actually having to read and interpret big instructions. Alright, so I wanted to mention the user study a little bit. We actually just got the results. They're not published yet. We're going to publish them later this year. But what the study, so as I mentioned, we ran 60 participants through. Each participant was randomly assigned a mode of work instruction. So some had this AR system, some had a model-based images, like 2D images of a CAD model on an iPad, and then the third set had, they weren't paper, it was actually on a desktop PC that was in the corner of the room. We tried to simulate one of our work cells. So every participant was randomly assigned one of those 3 modes, and they said, here, go build this assembly here. It's meant to look like a wing. It's actually made out of wood. It has about 30 parts to it and about 50 steps to build it. And then we would time them and we would grade them on the number of errors that they made, and whether they were major or minor, and how long it took to fix those errors, what type of errors they were, why they made them, that kind of stuff. So I don't have the results in this slideshow yet, but as soon as we publish them, I'd be happy to share that maybe at a future opportunity. But what it did tell us was we can expect a little bit in terms of time savings, that the assembly gets built a little bit quicker with AR, but it gives us a lot in terms of error reduction. The errors dropped hugely when folks were using the AR system.
Half?
Way more than half, lost more than half. So we were really pleased about that, because error avoidance is probably a much bigger cost saver driver in terms of, from our point of view. You know, if we can shave 10 minutes off an assembly, that's great. But if we have an error that causes us a week's worth of rework, that's obviously a much bigger problem. So we were really happy with these results, and like I said, we're going to publish the whole thing later this year. All right, that's about it. And I did just want to mention we just finished writing up a position paper that Christine suggested to us, which we just finished. As soon as it's approved for publication, we're going to release it to the area, the Augmented Reality for Enterprise Alliance. I think it'll be available to the members, published on the website. So it has all this information and a lot more about what we did and how we got here and some of the history and where we intend to go in the future. That's it.
Great, thanks, Eric.
What was the data rate for transform coefficients, whatever else you need to transfer back and forth with the tablet?
From the tracking system, we get 100 frames a second. But the camera doesn't give us anything near that, so we ended up seeing something like 15 to 20 frames a second on the tablet screen in terms of video refresh. Everything else runs faster than that. The camera is the limiting.
The data rate, actual bit rate, or anything that wasn't a video data, the transform model data.
Oh, like the animations and things? I see. We set them up. I don't really have the answer. We kind of set them up. We basically animated them in Maya from Autodesk. So I think it really just depends on some of the parameters you put in there of how how the data rate of the things moving around and stuff like that. But it's not really something we put a lot of attention.
What setup were we using for tracking?
For tracking, Vicon motion capture system. So it's really nice, really stable, low latency data, but also very expensive. And not practical really to outfit huge factory environments.
Great,
All right.
thank you. who discovered, because he's going to be speaking tomorrow, during the Energy and Utilities Domain Working Group meetings part. It's one of the domain working groups of the Open Geospatial Consortium. And the second I saw his name on the program, I said, oops. And very pleased that he was able to join us today. He's going to tell us a little bit about the Electric Power Research Institute and work, and I was delighted that I also looked up a YouTube video that showed that he's been doing this for years. So he's a bona fide developer. Since 2012 was the day on that YouTube video.
Yeah.
Just like with Moses over and so there's nothing there. Then you're starting to argue. Oh, that's
Okay. I was saying I feel just like Janet Jackson, but I'm dating myself, as I said. I feel just like Beyonce. All right, I'm John Simmons with EPRI, and I find myself in the ICT area at EPRI in what's called the Power Delivery and Utilization sector. I have to explain. Well, first off, I just want to say, it's great to talk to an audience where I don't have to explain what GIS is or what augmented reality is, because I usually end up having to explain one or the other. But now I got to explain what EPRI is. So EPRI is a 501c3 for the public good corporation that does research. And it does research on behalf of the public, and we're primarily funded by the electric utility industry. About 70% of our income comes from that. The rest comes from state, local governments, grants, federal government, that kind of thing. And we're divided into 4 sectors. You can think of a sector as like a division, except we call them sectors because we're EPRI and we're weird. The sectors are environmental, nuclear, generation, and power delivery and utilization. I work in power delivery and utilization, which is basically everything from the step-up transformer to the toaster. So it's transformer to toaster, and everything in between. And that includes information communication technology, and I work in that area. In my area, what I do primarily is I work with GIS, I work with data visualization, augmented reality, social media, anything kind of weird is what I do. And that's weird for the electric utility industry. We're not exactly a cutting edge industry. We like things that, are 100 years old or older, and everything's working just fine. Thank you very much. So anyway, that's all changing. And we're trying to kind of direct that change. If Henry Ford used to say, if I asked my customers what they wanted, they would have said a faster horse. So what we're trying to do is not to give the utility industry a faster horse. We're trying to give them better tools. So enough about that. I'm going to show a bunch of slides I came prepped with, and the second to the last slide is going to be some notes I took on possible areas where you guys and I could collaborate together. So this is a picture of Southern Company's trucks going out after a major storm. And Southern Company is basically has Alabama, Georgia, parts of Mississippi, and parts of Florida, the Panhandle of Florida. And some of the things we have to master are, first of all, standards, technology, communications, semantics, and I'll explain what that means by that, and processes. So before I came to EPRI, I was the IT manager for Southern Maryland Electric Cooperative. Anybody live in like St. Charles County or St. Mary's County, Calvert County? No, you probably wouldn't be here. But anyway, if you did live down there, you're in SMECO's territory, and I managed their IT assets primarily to support engineering and operations. And part of what I did there was to implement a mobile workforce management system there. Had all kinds of problems. At the end of the day, I took a look at what we had and I said, is this the best technology that's out there on the planet for this? The answer is no. And when EPRI called me out of the blue and lured me off to Tennessee to work with them, I decided that this was going to be one area I would focus in. And the gist of this project is that the platform that you use to work on assets in the field, and later I will say in a power plant, you should be able to use this on any asset, any kind of work, and the back office, what's going on in the back office should be kind of irrelevant. Give you an example of what I mean. When we implemented mobile workforce management at SMECO, we had ruggedized laptops at about $6,000 a pop. We had 4 or 5 major applications. Each one had a seat license of $80 to $150 per truck, per seat. And they didn't interoperate. If you wanted to do work, if you were working on an asset, you were in the asset management system, then you wanted to update your work status. You had to get out of that, get into the work management system. It was just a mess. Nothing talked to each other, nothing interoperated, everything had a different look and feel. So we came up with this, and we leveraged 3 technologies here. The first technology is what I call SIM. It's the Common Information Model. It's a standard that we use in the electric utility industry. At the highest level, it's a semantic model. So it's a model that describes the meaning of things and how they relate in the electric grid. Out of that comes a whole bunch of messaging, standard messaging. The messaging is XML, so it's a flat file, and that gives us a tremendous capability because the application receiving the message doesn't care how you produce that XML. And once that dawned on me, it opened up a whole new world to me. It's like you don't need seats anymore. You don't need to buy from vendor A, B, or C all their seat licenses. All you need to do is send them the message from something from the field, and it'll be just like you have their software seat on your mobile device. The second technology is why we're here, augmented reality. When I got to EPRI, they issued me a BlackBerry, and I'm tooling along with a BlackBerry. All of a sudden, it's like, no, here's an iPhone. So I get the iPhone and start downloading things. One of the first things I downloaded since I was going to Paris was an augmented reality app to help me find the Paris metro stations. And I'm over there, and I'm like, wow, this is really cool. I mean, I've heard about this, but no, this is really cool. And I got back, actually while I was over there, I was chatting with a developer friend of mine who was at the same conference. We were in a bar, so alcohol may have been involved. And I said, if we can project metro images and metro data on reality, why can't we do that with GIS data? And you can hold it up and you can see where your assets are supposed to be, and maybe you can tap on them and the menu come down, you can do some interacting and that kind of thing. And after a couple more beers, it sounded more and more reasonable, and we actually launched a project to do that. And we'll show you some examples of that. Well, you can see it, and this is a dummied up thing to show kind of all the capability all at once. But you can see there, you can see the conductor overhead, you can see metadata coming up on devices, etc. The third leg of this three-legged stool is context-aware GIS. In other words, what you're allowed to do in your look and feel is determined by what role you play at the utility and what device you are in proximity to. So if you're a lineman and you're near a high voltage transformer, you can get a menu that allows you to opt to look at the documentation for that, create a work order, etc. If you're a service person and your primary job is swapping out meters, you are not allowed to work on that. But if you were standing in front of a meter, you'd be able to swap out the glass or whatever you have to do. So it's context-aware GIS. All right, I've got a bazillion slides, and I could literally, and I have talked for 4 hours on this, but I just want to show you an example. We've got some programs going with utilities, Long Island Power Authority, Con Ed, Entergy in New Orleans, Gas Natural Fenosa in Madrid. And the furthest along, we've actually rolled this out. We've done a test implementation at LIPA. What you're looking at here is I'm standing in the concierge floor of the Long Island Marriott, so again, alcohol may be involved. And this parking lot is the parking lot for the Nassau Coliseum where the Islanders play. And what you see there is some dotted lines, and if you look in the kind of the center, you see a street going off, you can see a solid line. LIPA, one thing you got to realize is that every utility has their own look and feel, their own nomenclature. So whatever you write for them, you got to be able to show their assets the way they want them shown. In LIPA's case, they want the underground assets shown by a dashed line. So what you're looking at is several distribution lines that run under the parking lot across the street, and then you can see a solid line kind of snake off in an S shape off in the distance. You'll notice that the S shape, the solid line is on the ground because they don't have any elevation data. So it's not up in the top of the pole where it's supposed to be. But one of we try and boil down work to its basic elements. If you think about work, somebody's got to show up somewhere. They have a list of things to do, which varies. But every work order has a common. Someone has to show up somewhere at a time, perform a list of custom tasks, then they got to status it. Okay, so really, work, other than that list of things to do, is pretty much standard. So whether you're doing vegetation management, you're cutting down trees, or you're doing a switch order in a substation, really the only difference is the steps. And I work, one of the touch points that you can have with the utility industry is me through the IEC 61968 standard. I am in charge of the asset management, which includes GIS, developing the standards for that. So I also work on the work management team. And what I've tried to do is, because I have utility experience, is keep bringing those guys back to reality and saying, no, work is work, work is work, work is work. So I think I've driven that through their heads, and so the standard kind of reflects that. And we're trying to either use the existing standards or use this app to further the standards that have yet to be written. So, sorry, this means it's time for me to pick my son up at school. So anyway, and he's in Knoxville, Tennessee, so I'm not going to do that. So anyway, the way this operates is this is a very thin client. All it does is write and consume SIM messages. But that makes it very powerful. If you see an asset on the augmented reality view, you can touch it, get that context-aware menu, and then perform your operations. And that's a key thing to remember, that seeing the augmented reality is kind of cool, but it really needs to be integrated into the workflows. And it needs to become an enabler of the workflows in order to be accepted. So anything you can do in augmented reality, you can do in the map view. Here's an example of the map view. See, it is time to pick up this. This reminds me of a great story. I'm Irish, so I got a million stories. I was working for GE Global Exchange Systems in Gaithersburg. And one of our big clients, and we were doing B2B e-commerce. A third of the world's B2B e-commerce was going through our van in the year 2000. And one of our big clients was Ford Motor Company. We had Ford Motor Company and all these guys sitting around the the sales guy was going through his presentation, and somebody sent him an email, and in the subject line it said, "Are you still with those idiots from Ford?" And it kind of came up in the lower right-hand screen, and you could hear a pin drop. In fact, you could hear a career drop. So, don't let that happen to you. So anyway, this menu comes up. It's context aware. I'm not going to demonstrate. I'm just going to point out some things you can do. Storm damage assessment, huge use case now in the electric utility industry. Your typical storm damage, you know what storm damage assessment is. There's a major event. They got to figure out what's down, what's broken, so they send out teams of folks. I'd like to say they send out teams of qualified people, but that's not the case. So they send out people with a clipboard and some NCR paper, and they go out and they survey the damage. So they send them out, say, at 7 in the morning. So they fill out all this NCR stuff. There's no data validation. There's no guarantee that they're filling out the required fields or anything. Then they do something like come to a substation where somebody types them in. And of course that leads to other errors. But it gets into the system, whatever the system is. But what you've got is a 5-hour lag there before the first problem can be addressed. And so right there, you've already ticked people off. Okay, you got 5 hours waiting. So storm damage assessment is huge. The other thing on this menu is view the manual. Think of manual as anything. Right now it's PDF. It could be a movie. It could be an augmented reality vignette, whatever. Redlining. Redlining is a fancy way of, in the utility industry, saying editing. Something's wrong out in the field. You got to replace it. And asset history. So you want to find out when was the last time this was serviced, etc. You can use this option. But what you have here is you're accessing 4 different systems, 4 different back-end systems with the same interface. So that's 4 seats you've eliminated. You've got 10,000 trucks. You just saved yourself a couple $1 million, several $1 million. All right, storm damage assessment. Right now it's scoring-based. We've got some schemas to make it easy to customize. Where we're heading with this is we want this to be simple. We want stupid people to be able to do storm damage assessment. So you're driving along a road, you look down the street, and you see everything is gone. So basically, we want to be able to draw a box around it and then create a bill of materials to send off to the materials management folks so they can get this, send it out on the next truck. That's what we're building right now. We mentioned Tom Caudle earlier. Tom just retired from the University of New Mexico. He and I have been working on this application. It's a neural net application where we're learning what above ground assets look like. Believe it or not, most utilities do not have very good GIS data. So what we're trying to do here is use Google Street View and create a bot that virtually drives down a street and recognizes and positions all of the utility assets. So it's got to be able to tell a utility pole from a flagpole, etc. This is a very early example of what we're doing. But now we're going to take this, we're actually pretty far along. What we're going to do now is put it in EPRI's high-performance computer and start dumping in tons of data so it learns what all these assets are. And then we'll download it to the tablet app. And you'll be able to go out and a person that doesn't know anything about utility assets will be able to point that up and see that it's a 25 kVA transformer on a 35-foot pole at this lat long to 6 sig fix or to 9 sig fix. And we'll be able to map that. And then ultimately you'll be able to go out there and just take the iPad and scan it and get the storm damage assessment. What's even better is we've got another project on wearable computers where we're porting all of this to kind of a physics, or I'm not going to use the G word, but to a goggle technology, industrialized goggle technology. And we've got other applications. Again, this is a view of, I don't remember what network, but you can also, we're attaching this to other data to look at like power quality data and everything. So basically anything out in the field will have the same capabilities as you do in the back office. So that's kind of where we're heading with this. Where I see you folks and I collaborating, EPRI does a lot of hiring. Most of our work is contracted out. I'd like to talk to folks about harmonizing the SIM with some of the geospatial and the augmented reality standards. I am doing, in May, I'm doing a workshop for the Industrial Research Institute on augmented reality. I'd like to invite Boeing to come to that. I think you're even a member. But this is going to be, this is not utilities, this is just all kinds of industries that are interested in augmented reality. And I need to get them involved with you and you involved in them. Then EPRI projects, if you're interested in working with EPRI, we've got a big projects with Enel, which is the Italian utility, with EDF, which is Electricity de France, the French utility. Again, funny story, I'm working on this app in my little sector, power delivery and utilization. EDF wanted to have a little conference on that, so I go over to EDF and they're showing me their stuff, I'm showing me my stuff, and they get to one guy and he says, okay, now I'm going to show you this augmented reality work that I'm doing with EPRI. And I'm like, what? It was another sector. Of course, you know, utilities are highly siloed. Well, we like to service our members by being highly siloed ourselves. So it turns out that nuclear has their own augmented reality program. And now I find myself in charge of augmented reality all across EPRI because I brought that point up and it was a source of major embarrassment for all involved. So now we're all working together, and tomorrow in the afternoon I'm going to talk about, again, kind of repeating some of what I did here and also showing you what the new folks are doing. They're using a Unity platform to do a lot of what Boeing just showed you. Very, very similar stuff. Very interested in the interoperability work. One of the big dangers in this area, especially with smart grid technology and stuff, is that the utility invests millions of dollars in the technology and it's a dead end. So we need to get involved in the interoperability and help push this. Especially interested in the stuff with the browsers. Again, I'm in charge of crazy ideas. I have this idea of creating a holodeck using augmented reality where you actually look around and it looks like you're in a substation or you're in an underground vault. And I have some ideas on how to do that, but if anybody wants to interface with me on that. And then anything you guys can come up with that you think the utility industry might be interested in, I'd be interested in hearing it because, as I said, the utility industry is not exactly a bleeding edge group of guys and gals. They like the old stuff. So we need to drag in these people kicking and screaming into the 1980s and get them some stuff out of the field. So that was a little bit different presentation. Are there any questions? And there's my contact information.
You said you're about tomorrow. Is that for the...
It's the Energy and Utilities Group, working group. It's in the afternoon.
I'll catch up with you at some point anyways.
Oh, and if you go to YouTube, the EPRI's YouTube channel, if you just put in the search engine EPRI augmented reality or EPRI field force data visualization, the YouTube video will come up. It's a couple years old. You'll see the back of my head. It looks like this. And you'll see me fooling around in the parking lot EPRI with the app.
I'll get to the question anyway. Positional accuracy. It's vain that everybody's like augmented reality, especially with utilities. You obviously got the car park demonstration, you're talking about going out climbing cables and various other bits and pieces. Devices that you're using at the moment, how you're actually getting around user positional accuracy.
Well, to get closer, we're using something called Bad Elf, which you plug into any of your iOS apps, and it gets you down to, I want to say 1 meter or 3 meters. So it gets you closer. Then you actually use two of them. One is a stationary position, and the other one is a roaming thing. And we're using this, we're helping out nuclear in, nuclear is big on concrete, okay? You pour concrete, you have to have the rebar in the right position. So one of the things we're trying to do with them is show an augmented reality view of the position of the rebar. It's got to be 21-inch centers, or I don't know, there's Chernobyl like meltdown or something someday. And so we're doing that, but also when they pour the concrete, they have to put vibrators into the concrete to make it settle out, to get rid of air bubbles and stuff. And that has to be done at regular intervals. And so we're using the two bad elf technology to show them, you know, you've done it here, you've done it here, oh, you skipped this one, that kind of thing. So that gets you down to a couple of, less couple of feet, a foot or two. And we've got other technologies that we got a remote control car that measures light, like for parking lots and stuff. It's accurate to 2 centimeters anywhere in the planet. It's the most accurate remote control car on the planet.
Wow. Okay, let's leave it at that.
All right. When now we eat,
John. Yep.
eat and drink. Okay.
Yes. Well, actually, right now we're going to go to, we have 2 more presentations for the end of it. And wires.
I actually scored. Yeah, I usually trip over the corner at least once. You're welcome. Well, I don't stand behind the podium.
Got audio?
But if it's on the same level, it's the way to walk.
Don't touch that. Greg? With no sound.
Oh, the mute button.
Is gray button on top of that?
Big round gray button.
Hello?
Yes.
Great, wonderful. Thanks. So thanks, sorry to cut in, but I've got a place through Airbnb and I have to meet the guy to get the key at a certain time, so I can go first. So my name, I'm just going to talk for about 20 minutes. My stuff is going to be quite different from what other people have talked about, but it's nice to throw it all into the mix. I really enjoyed seeing all of everything that's been going on here from all these different people in all these different sectors. This is, my name is Bill Denton. I'm a web librarian at York University, which is up in Toronto. That's my website. The slides are online. They are there. And they're there. I'm on Twitter and on GitHub. I'm going to be talking about 3 things today. I'm going to be talking about stuff and standards and sites. And I'm coming to this from this world of libraries and archives. I won't be going deep into anything, but I'm just going to hit on a few points, and there's some more stuff that you can follow up on. And there's sort of one question I've got behind what I'm going to be talking about, is that geolocation is the missing ingredient in the libraries and archives have got. So stuff. The key point about stuff coming from here for the libraries and archives world is that we have lots of it, and we want it to be used. We make it openly available for people for any kind of thing they're doing for use and reuse. We've got libraries with books, data, journals, multimedia, all kinds of stuff that is there for people to use. In archives, they have photo collections, paper stuff, ephemera, special collections, documents, records, corporate things, all of that, all of which can be used, and we want people to use it. If, just on behalf of all libraries and archives, if you're doing any kind of augmented reality thing, and there's something that where you think we might be useful, or it might be something that we are happy to collaborate with you. At the public library, university library level, national library, digital library, we are happy to collaborate with you. We all get paid to work and help get content out to people. Probably though, when you think about stuff in the libraries, you would think about books. So this is Kim Suckerman. It's a novel by George Pelecanos. When I go traveling somewhere, then I like to do site-specific reading. I like to read stuff that is set in the place where I'm going to go. And Pelecanos, he lives in D.C. He's been writing novels for 20 years. This is one of 4 historical novels from the D.C. Quartet, set in 1976. If you like blaxploitation movies from the 70s and rock and soul and funk from that time, you will like this book. It is, and if you know about Pelecanos, or you know about this title, it's easy to find this. You can go to a library catalog, you can search for it by name, look it up. That's easy to do, and that's sort of a solved problem. But that's not what I'm talking about. Pelecanos, as I said, is very specific about location in fiction. So this is a bit from the beginning of the book. Dimitri Karas swung the Carnegie into a space in front of 1816 R Street to cut the engine. Here we are, said Karas. Vivian had a look at the building, the former mansion with the peeling stucco facade, now 4 floors housing 3 units per floor. A small yard up front packed with ground where a fat gray cat with huge ears lay on the grass watching a cluster of gnats hover in the air. This is about location. This isn't about the usual stuff that libraries record about books, like the title and the author and publisher. This is about content inside the book. So I just got into the area this morning, and it came right here. I haven't been to this place to look at it in person. This is in Google Street View. This is, I think, the building on the left is, there seems to be no 1816 R Street. The building on the left is 1812. The building on the center is 1818. Dimitri Karas, it says in the book that he had a bay window, so perhaps this is based on the house on the left. So if you're doing a George Pelecanos augmented reality view of Washington, then you would want to know this. You would want to know that that was there, that was a location in the book that he's talking about. Or if you're in D.C. doing some kind of a tour, if you're in D.C. and in a particular place you want to understand about Pelecanos, and you want to be able to be there and know that this is going on in there. If you've got it all set up right, then you could set it up so that this worked as a channel and layer tonight, or some app like that, got the points and the locations. But what about the standards and library standards? What is going on here that can help support all of that? There is there's a big library consortium in Ohio called OCLC, and they've got a service called MapFast that maps locations to these subject areas. If you give it a lat long, it'll give you back some JSON in a particular format. That's a fragment of it there. And it tells you about the subjects, the places that are near, that it knows about. Then that Washington, D.C., DuPont Circle, is the important bit there. That is a Library of Congress subject area. We call that LCSH. DuPont Circle is just a short ways away from that place. Little bit of sidebar, if you want to try it, there's someone who works at the Library of Congress named Ed Summers who did this. If you go here on your smartphone, it will look up and tell you all these Library of Congress subject headings that are near you. It is telling you the aboutness, as librarians talk about it, near you. So this LCSH, it is a standard for aboutness. This is a standard way we have of describing what things are about. We have a number of standards that work like this. You have the Dewey Decimal System, things like that. But this is a main one that we use to talk about things in words and say what they are about. Once you know a subject heading like that, there are lots of catalogs you can look it up in to find all of the other things that are also about that subject. LCSH, just as a side note, LCSH goes back to 1898. So libraries have been in the standards business for a long time. There are lots of standards that go back quite a ways. So this LCSH is a standard that we use to describe our stuff. And so the stuff is described by standards. Now I'll talk about standards. We can look up DuPont Circle at the Library of Congress's website at a place at id.loc.gov. And all of the LCSH is all listed there. This is all fully open. It is a fully open standard. This is telling us about this subject heading. It's also linked. There are links to the representations of this data. It's available in alternate formats. It is part of the linked data world. I'm going to show you an XML. Then here we are. It's a bit ugly, but this is a fragment of what this looks like in RDF. There are, you can see it's talking about DuPont Circle there. You can maybe see it's talking about MADS, RDF. MADS is the Metadata Authority Description Scheme, another standard we have for talking about authority records. This is an authority record. This is like the source of truth. This is a source of truth for the aboveness of things, these LCSH records. So here's the thing to remember about library standards. I've just been talking about the LCSH. We make lots of standards to fit our specific needs. They're listed there. We use them particularly to talk about how we describe things, digital things, physical things. But these are, we have made up a number of them to suit our particular purposes. Everywhere else, then we use web standards. So we use, we don't let, we now, with the systems that we're making now, we are using Atom, GeoJSON, and JSON, we use RDF, things like that, to talk about using web standards that everybody else can understand and consume with all of their own familiar tools, programming languages, libraries, all of that. So we've got our standards. We use your standards. You can use our standards. If they're all open, if you need them to talk about something or describe something, then you're welcome to use them. Everything all fits together with these linked data approaches. An example about how things fit together. Before we hit a point and we wanted to see what it was about, but you can go the other direction too. If you have a Library of Congress subject heading, you can find out where it's about, because it's going in both ways. So if you go back to that FAST project I was talking about, you can look up DuPont Circle, and it gives you back this. Again, some XML. You can see there's some stuff from schema.org. We've got some Dublin Core going on. You can see too that it is saying there's a same as assertion to geonames. So we're going from here over to geonames, and if you ask geonames about this, then it gives you back a latitude, longitude, and altitude, and it points you to Wikipedia, and then everything goes up from there. We're sitting there right in this world of linked data. So we've got these standards, and these standards are used on sites. They're used on our sites. They're used on other sites. There are many, many sites out there that I'm talking about. I'll just talk about really three. There are, first of all, the Digital Public Library of America. There's about 6 million things in it. It is getting in content from libraries, archives, public libraries, all sorts of sources all across the states. Everything there is freely, it's open, accessible, available, not hidden behind any subscription walls. Digital content, there's lots of scanned stuff, photographs, more and more in there. You can look things up by a keyword or subject in the traditional way, but a small portion of the content is geolocated. And there's a map view. There we are looking at this area. You can't see what the numbers are on there, but there's a fair bit of geolocated content all around you. And with the API, you can ask it for what is near you, and then you go back some JSON LD, some linked data in JSON, and you can use that for whatever you want. Another one, sort of a similar one going on in Europe, is what European had, which came before the DPLA, was an inspiration for it. This is another huge site, a lot of digital content collected together from places all over Europe. A lot of historical, of course, a lot of historical stuff. Again, a small portion of it is geolocated, and it's searchable by location. You can ask it what is near you, and it'll give you back some results. There are a couple of platforms that are in effect standards for how we do things, standard platforms we use. Hydra and Islandora are two leading open source ones. They are both built on a system called a Fedora that looks after the actual objects that are sitting on disk, but Hydra and Islandora, Hydra's built in Ruby and Rails, Islandora is built in Drupal, and they're operating at a higher level to make it easier for people to manage all the content and to provide user interfaces for them. At York, where I work, we use Islandora. This is an example of it. We got the photo archives from the old, an old defunct Toronto newspaper called the Toronto Telegram, and they went under in about 1972. They have photographs with boxes and boxes, like shelf meters and meters and meters of photos like that we're digitizing. We're using some of these in the project of Kensington Market, which is a neighborhood in the west of the center of downtown. For the last 100 years or so, it's been an area, it's right beside Chinatown, been an area where a lot of immigrant populations were moving, and after they've gotten settled in the city a bit, sort of found a feeling they would move on now to make way for new people. Doing some work with on the history of the Portuguese Canadian History Project, and this photo is part of that. This was taken in Kensington Market in 1965. Digitized. We put it up on our site using Augmented. This is part of our stuff. This is a thing. It's a piece of our stuff that we've got in the box down in the basement, and then we digitized it. And we put it up on our site. And when we did it, then we geolocated them. We discovered there were some standards when we did it. This is a thing called MODS, the Metadata Object Description Schema, an open standard that we've got, comes from the Library of Congress. We use it to describe digital objects. MODS are very good for describing any kind of digital object. It was a good system to use. You can see down at the bottom, sorry, it's more XML, but down at the bottom, cartographics, coordinates, you've got a latitude, you've got a longitude. This tells you exactly where this is. This is, if you query that URL, there, you get this view back in MODS. You can also query this URL here, and Islandora will give you back a Dublin core again, much simplified. You can see down in the very last line there. It's also got the coverage, it's got the latitude and the longitude.
I'm sorry. How did you geolocate these pictures?
These by hand on.
So somebody went out and like, here.
Yeah.
Okay.
Yeah. In some cases, we could read the street address for them. Other times, we'd people, Anderson Hodge, or who works with a colleague, would go down and I checked them. So we'd go down to Kensington Market, look around, find the building, see if we can stand in the right spot, and then using a smartphone or Google Maps to find it, to get it back on. No mass project for doing it. It's looking at the actual street addresses of the place that we're finding. This is the hard way. That is a hard way of doing it. There are other ways. The New York Public Library now, I think, is working on a sort of a mass project to digitize a lot of their historical records, their historical photos. The New York Public Library does astounding stuff, and I think they've got, they'll be releasing something soon where they've done on the order of tens of thousands or just thousands of historical photos all geolocated.
I would think that somebody could write an app where you digitize that picture and then basically search an area using Google Street View automatically, and you can tell if you find you've got the right view, the right position, and you line it up. And then you can basically feed all the photos into some sort of scanner, and they come out the other side.
That would be a wonderful application. We would love it if that existed. And if you can make that, that would be great.
Not ideal people.
That would be wonderful. There's some, you can imagine the problems when you deal with historical photos. The stuff looks a lot different, but that would be a very extremely useful thing.
You got a problem, I know people that can take care of your problem. And they can make it look like an accident.
So we've got all this stuff in Islandora. Islandora is built on solar, so you can talk to it if you know how to use solar, search engine. This is a query that says show me everything you've got. That's what the 1 kilometer at this point. And it'll give you back a list. Formatted here, but you can say, tell me everything that you've got that is near this point. It gives you back a list in some JSON or XML, and then you can use it, whatever you want to present it in, whatever sort of format, whatever application, you can present it there. So this is how it all ties together. We've got these sites, and they store this standards described stuff. We have lots of stuff that we want people to use, and we use all these various sorts of standards to describe all this stuff. Again, some we made for ourselves, for our specific needs. In other cases, then we use these web standards that everybody else uses. And then on our sites, we use these standards to just describe this stuff, make it usable, and make it findable and reusable by everybody else. So the key thing, I think, is that not much of this is geolocated. The standard ways of finding, if you're looking for something that is about something, then using keyword searches, then our systems work fairly well for that. They could be better, but they work fairly well. There are established ways of doing that. But what is missing is that very little of this is geolocated. So it seems, I hypothesize that that is a direction that we should be going in, and if anybody has any thoughts about that, then I would love to hear it. Thank you very much.
you got from Cornell?
Right here?
Young Penn Lee, Noah Snavely, and Daniel P. Huttenlocker have developed an application that will take an image and find where it is on Google Street View. And they all work, or they all are at the Department of Computer Science, Cornell University.
Thank you. I will look at that.
That might be something you came here to get.
Wonderful.
That's great. Any other questions or comments about, I was thinking of Raj, when I was listening to what he was talking about, I was thinking, Raj should hear that. Because the open FOIA registry, wouldn't it be interesting if there were a way of looking in and using these web standards and the kinds of things that he's talking about? Can you see a connection, or am I just imagining that connection, Raj?
No, I think that's the idea.
And if you have all these, you have this a way of expressing those poems. You have these repositories, and these are other assets, whether they're written assets, or they could be nonfiction, fiction, photographic. But these assets that are really interesting and diverse and open, public. Another
I actually have some examples within the library commons photograph.
So you should try to get his contact information, see if you can follow up. Another question I have is, do you know NISO? You didn't mention NISO at all. National Information Standards, and they, so the Secretary of Rick's come and spoken with us a few times because they have some technologies and some specifications that they're working on for discovery of information in library assets and archives. So Information Discovery Project, I think it's called.
As far as I know, there's going on that.
They just issued a report, it's only about 6 months ago.
I don't think it's had much traction.
Okay.
And I think,
You're the librarian, not me, I'm just,
and I think a direction that the people that are making that these big platforms that they're going is just to get the stuff out there and chase on something in a nice format everybody can use instead of getting
silos.
Getting bogged down in something. If some sort of standards defined, we're just getting stuff out there.
And you didn't speak very much, but I guess you are thinking about how can the stuff be used in AR scenarios. You're here primarily to tell us that the stuff exists and there are interfaces to that that are open and public and well-defined interface to that stuff. Examples, we can use them for living sites. How can people use them for AR experiences?
And all of the AR is increasing interest in the library and archives world. And if there are, but the next problem about which application should we use? How do we see the work with all these 3 different smartphone apps is a problem for all of us, and then the people that are accustomed to things, and it's getting to be a complex world. Whereas if everything just work together, working together, then problem solved for us would be a lot more. We would be getting a lot more.
All right. We had some people disappear, but it's not because they don't like Mike. They just had to go and get keys and cars, and I've heard every flavor of reason. But thank you, Mike, for joining us this afternoon to talk to us about the Willa browser and the project, what you've done with the OWS-10. The OWS-10 will be the subject of the OGC Web Services test bed and interoperability test bed. No. I'll be wrong. I met Mike a few years ago when he I was running a developer contest on the basis of open data about the city of Basel. And one of the participants, it wasn't just open data, there was data sets about the city of Basel. And one of the companies or one of the organizations that provided a data set was the utilities company for the city of Basel. And they said, yeah, here's a data set, and I got data set about tourism and about other things. And the idea was, if I just provide this data, put it out there, just like Bill, put it out there, somebody can make an augmented reality experience out of it. On Friday afternoon, before the deadline for the contest, what do I get? Now, I was after the close of business on Friday afternoon. Mike writes me an email and says, gee, can I get a hold of that data set? I already submitted a request by the interface, but maybe I won't get it until Monday. I could really use it this weekend. So I just went ahead and gave him the utilities data set and a couple of others. By Monday, he could use that to make an augmented reality experience where you could walk around in the city and see the underground utilities infrastructure in 2.5D. And then we brought that together with the utilities,
Yep.
the man who provided the data set. That went absolutely nowhere. It was 2.5 years ago, I think. But we do have...
Talk to me about it.
well, we'll talk to you about it. Great, okay, thank you. That's how I met Mike.
Thanks, Christine. Okay, I appreciate this is the last session of the day, and everyone's there going, bit of clock. So I'll try and get through this relatively quickly. So we started the day very much talking about it was a good presentation from Gobi, and George was up here talking about the AWS 10 test bed and interoperability, all those good things. So I was actually one of the participants of the test bed developing a mobile client, using our mobile client for testing to the standards. So instead of going into the actual detail of what those standards are and things, this is very much from an implementation perspective. So very quickly, a shameless pitch here for myself and my business. What do we do? You can read that off the slide, a lot of what it is, but generally we have a mobile geospatial AR browser, a very long way of saying it's a mobile app. We do geolocation and things. From a personal background, I've been working with GIS data and organisations, utility organisations that use GIS data for about 14, 15 years, somewhere around there. Predominantly the water, but also been doing electricity and that type of thing. Coming up 3 years ago, I left the software company I was working for and basically thought, hey look, utility data, it's underground, you want to see where this data is before you actually dig in the ground. AR would be really cool way of doing that, very much as we were saying earlier on. Let's give this a go. This is what we developed. So I started Augmented Technologies, and that's essentially what we do now, along with GIS consultancy and GIS data analysis for these organisations. So, okay, Raj will probably correct several things within this slide. I won't go into massive detail, but the OWS 10 Open Mobility thread run through the OGC interoperability program. What's it about? In essence, it's about testing existing and emerging standards for the interchange of information. So as I mentioned very briefly just now, I was one of the participants, and basically we were testing two main standards, which is GeoPackage and AWS Context, and they're very complementary between the two. So the role really was to take those standards, get them into the mobile application and see how they work along with the other participants. Client applications, but also the server technology as well. The Open Mobility thread is one of 3 threads that were being run. I was going to put the other 2 names up there, but I don't remember CCI, so I deleted that bit. There you go. So that's essentially that. So these are the 2 definitions from the standard document. I'm not going to read them out. Essentially, GeoPackage is a SQLite database, as Gobi was explaining. Single file, very portable, cross-platform, an excellent container for geospatial data. In OWS Context is a lot of what we were talking about today, and the likes of Martin were talking about, is how to exchange, I suppose, the semantic information about the data. You want to look at an area, you need another client application, or server application, or desktop application to view the same data, not necessarily data, but the area and rights information, things like that, about a specific area. Very much to do with situational awareness. So, in terms of what we did within the application, this was the original architecture, pretty much the original architecture. At a high level, we have our server, which has got a catalog service on it, which lists all the endpoints where it can pick up geospatial data from, and various semantic information about that, in terms of who published it, what the license rights are for using the data, how long before it should expire, all that stored on our server. That information is pulled down to the client, which receives it, builds a data set, and then goes and talks to the individual services, the endpoints, to pull that data down to the client. The data stored on the client was file-based, so there will be many files in different formats on the client, on the mobile device, and it has to understand each different type of data format. So that could be geographic markup language, it could come from an entry server, it could come from Wikipedia. So all of those converters, all those readers have to be implemented on the client. So what we actually went from, a lot of that still exists at the moment, but on top of that, we've used the OWS context for telling the client where to get data from, and like I say, replacing that web service in that proprietary format. And on the client side is replacing the file-based system, storing it in raster formats, image formats, GML, etc. Now it's all stored within geopackages. I won't go into the technical details of exactly how it translates that data, but it obviously simplifies it on the client side and also enables the client to send those geopackages to other compatible devices compared to sending 100 files to cover a 10 kilometre square area. It can just send one SQLite database, which you know is going to be cross-platform compatible. So that obviously makes things a lot easier. Okie dokie, so the data process, what actually happens on the client, it receives the context document along with the orientation and location sensor information to understand what data it needs to load for a specific location and orientation. And this is a slide that may come up tomorrow, I'm not entirely sure, but one that I put together. Very much standard-based browser, very much based on OGC standards, coming from my background. So it combines those information. That information, which is obviously OWS context, is an OGC standard. It then uses the simple feature specification to actually translate data that it receives from a service endpoint. So that could be an Esri ARC REST service. It could be from an RSS feed, like I say, from Wikipedia, or it could be from a WMS or a WFS web feature service. That's all translated internally into simple features and then pushed into a geo package on the client device, again using that simple features. Like I say, those geo packages could be sent off to a third-party application, but the data is then reread back out to that geo package and translated into three-dimensional objects, which is then rendered within the browser. So a little bit of to and fro on the client, but it does mean that you can get some exchange between things quite easily. This gives the client application two options for delivering content, or two primary options. Like I said, first of all, within the context specification, there is the serviced endpoints. So there is this, it's essentially an atom feed. That's the initial implementation of it. Is an XML atom feed that has offerings within it. And one of the beauties of the context document is that it can specify multiple offerings for one set of data. So if the client application doesn't understand shapefiles, the context document can also specify GML in it, can also specify various other formats. You pick which one you actually understand and then use that. So the context document comes down to the client application. Like I say, that then goes off to the service endpoints, which may or may not be OGC web services on the right-hand side. That data is pulled back and then stored internally within a geo-package. The other option is a geo-package is sent to the client with an embedded context document. So you're actually receiving the data and the various semantic information about that data within one database. That comes down and again it goes through the same process, reads the data directly out of the database and then renders that content to the user. The current benefits of this, really well, pretty much mentioned them. It's lightweight in terms of the geo-package. It supports at the moment raster data and 2.5D vector data within it. The context document, unfortunately, everybody that was involved in the interop experiment has disappeared, thanks to Captain But really think it would be valuable for people that are interested in the interoperability experiment that Martin was talking about earlier on, to look at OWS context and see whether I think it should be extended within the context document, that it can accept ARML, because it's a very good way of describing where you get the data from, how to understand the data, and the various information around the data. Being an atom feed as well, you ignore what you don't understand, as I was mentioning just now. If you don't understand a particular format, you don't actually deal with that, and the client applications have to continue, not fall over at that point, but just continues and moves on to the next thing that we can understand. So that's very good in terms of benefits. This is a quick slide, just some of the challenges in terms of implementing these within A mobile client, and B, an augmented reality browser. We did some quick testing, so quick testing wasn't that quick as, from these figures, but actually taking a geo-package, how testing it to destruction. We actually had some point data, some digital terrain model data for New Zealand, New Zealand Land Care and Research. This data is available on their website. Something very said, could you give this a go? For just the North Island, one tile of 6 for the North Island of New Zealand contains 18.6 million points in terms of a grid file. So we took that file, loaded it into a geo-package, 18.6 million things, and using a desktop Java application in our implementation, you can actually query that and for a particular bounding box area, read the data out of there in about 2 minutes. On a smartphone, that took 33 minutes. Clearly not particularly acceptable. I will say that that database didn't have any spatial indexes in, but that's quite a considerable difference. Some of the other things in terms of, one of the things that we really wanted to try out within the interoperability, I'm struck that word, experiment, is having a pure Android implementation to read the SQLite database. Unfortunately on Android, it's not distributed with a version of SQLite, something that reads SQLite that actually understands all the things that are required for the geo-package standard, so that have to be worked around. And like I said, one of the primary things out there is spatial indexes, which will really speed things up. So that isn't available just because of the OS. Hopefully Google will roll out the later version of SQLite at some point. And a couple of other things around there in terms of availability of data and things which I'm sure is always the same within the test beds. We can generally do R&D-based work. So some of the future work that we actually want to build on this, and I was alluding to this in a comment with Blair earlier on, is very much, I was thinking when I was outside, I was doing some screenshots earlier on, that I don't know if this is a problem unique to England, because everywhere I've been in the States is flat and square. You just have this grid system, and you go, hills obviously don't really matter around here with these things. In England, we have lots of hills and lots of bendy roads, so this isn't a screenshot that I show very often because it's it's not great, but very good from this example. These digital terrain models is actually processing and using these within AR, and I think this is one that should be a focus area moving forward with AR, is obviously we've talked about quite a few problems today in terms of field of view of cameras, accessing various low-level APIs and bits and pieces, but terrain can make a massive difference in the perception and the way that you're actually viewing this data. So this is some work, and hence why we're looking at New Zealand data, actually trying to build a terrain model on the mobile app and experimenting with different ways of doing that. And this is to overcome the problem in the screenshot that's on the left, in terms of looking up a hill. The data, the world is in fact, obviously apart from the places that I've been in America, you look up a hill, and if you don't actually apply terrain or 2.5D to the GIS data, you end up with this effect, that the data's actually superimposed into the correct place, but because it's on a hill, everything's shortened. And the vision that you get just isn't accurate. So that's some of that. And going forward, we're going to replace our catalog service. That's something that actually, the web service, purely sticks out the context of documents. I think I'm right in terms of these two standards. I wasn't in the context suite, which I believe is on Monday, but certainly in terms of GeoPackage, they're looking at extending the standard. At the moment, it just supports vector data, single feature vector data in 2.5D. But there's going to be some work, or there's certainly going to be some thought going forward in terms of putting in AR and L2, 3D data, levels of detail, applying styling within the GeoPackage and things like that. And like I said, there's a couple of ideas of what may be going forward in terms of the context document and the additional things that are going in there. We certainly explored annotation and markup within the test bed, but there was pretty much I don't think hopefully I'm not being unkind in saying it's a relatively academic exercise in terms of the exploration compared to the implementation exercise. So, like I say, pretty short, pretty quick presentation hopefully, but if you want some further information, I will say that the implementations that we did, Java, pure Java implementations for reading and understanding code context, and also for GeoPackage read and write, is open source. That's available on GitHub, so you can download that from the Open Geospatial section. GeoPackage information, geopackage.org is gradually growing, and there's sample data on there, and it's well worth checking out what's being posted up on there. And I think there's going to be some reference documentation, best practice documentation in terms of implementing that going up. And obviously, if you're HSC members, you've got a portal and how to look at the standards and things like that. So, in not doing demos or anything today, like I say, it's beer o'clock, so we won't get tablets and things out now. But I am about tomorrow, hopefully everyone's going along to the AWS 10 showcase here tomorrow morning, and then I'll be available at the back for some demonstrations in terms of showing the data, A, from the test bed, and B, that we'll use in terms of utility data for, within an application, basically, within our browser. So there you go. That's about it. If anybody's got any questions, then I'll
Good, thank you. Questions? Eric, yes?
Yeah, the performance issues you had, what was the nature of that? Was it just amount of data? Was it processing power? Did compression help?
Compression actually doesn't help. It's actually the reverse, because the way that basically we're compressing the data, not compressing streams and things, so you have to deflate the data to actually read it. On a couple of devices, actually disk access to the SD card. You're talking that 18.6 million point database, 1.5 gig on an SD card. So it fits on an SD card, but just the speed of accessing that on the device was slowing it down. And like I say, in fairness, that database didn't have spatial indexes in it, which would speed things up as well. But yeah, generally processing power. The application is trying to do an awful lot of things. It's trying to read the data, it's got to get it into internal structures, it's then going to generate three-dimensional objects out of it. Because for various reasons, points and lines, like you would have in a standard GIS application, doesn't really work very well there. You need something to click on, you need something solid to see. So we have a philosophy of dynamically creating all our data, which is quite reasonably different to a lot of the other browsers out there. We take data from corporate data stores, from corporate GIS systems, and dynamically generate the content on the device so you can update the data store. So the application is trying to do all that whilst reading the data. So there's a couple of elements there from that perspective. Hopefully that
John Simmons had a question. John?
Maybe this is a over-beer conversation, but I just, so how do you make money? I mean, are you selling a product, or are you primarily looking to work with utilities to implement, or?
A bit of both. We've been developing the application for a couple of years, and obviously learned quite a few things through that. I mean, I asked you a question about location accuracy earlier on, and it started with a very laudable goal. Okay, this is really good for, let's develop this application, let's work with utility organisations to have a mobile mapping client which can do augmented reality. There is a couple of issues with that, but the primary issue with it is device accuracy. In terms of the screenshot that I showed there, is that if you've got 3-meter accuracy or even 2-meter accuracy of where you're stood and you're trying to dig a hole in the ground for where your utility pipe is, if you're 2 meters out, that's it, you're just completely lost at that point.
I don't, it's going to be a while, I see, before people use this for locating where you're data. You're still going to, it's going to be a one call.
Safe practice, various other things, it's just not going to happen.
But you also have the accuracy in the land base, which causes, at SMECO we had a major transmission line going down the middle of the Hudson River because the land base was off. So we looked at that.
Exactly.
And we're pretty sure that the transmission line was in the
middle. Yes.
But yeah, to actually answer your question, essentially we have a marketable application, and we're looking at different industries other than utilities, but also do consultancy around.
We developed our technology with intent on open source. And we're working with a company, and at some point they said, hey, we can sell this ourselves. And they stopped working on this, took the open source stuff and the commercial version of it, which is fine. But, we're looking to work with people, but our ultimate goal is to have an open source technology. People just grab the pieces they want to implement.
Well, I think there's so many different parts to AR, but there's an open source client that's to bring the data into the right environment. And then there's a lot of back-end processing that has to be done, and that may not be an open source. I know that we're running out of disk space again, so we're going to close the recording.